My friends, welcome to my channel Focusing FreeCAD. Today I am going to work on Model Mania 2000 Phase 1 and Phase 2, but the catch is it will be a one-click transition between these two phases. About a year ago I worked on this model on part workbench using split slice apart tool. About a year later, today I have a new realization that if I used a different tool, the process would be much simpler. I will still be using the part workbench, but I want to use the connect object. That way the transition will be smoother, the building time will be less than what it was last year. With that, let's go ahead and start a new model and get our technical drawings sorted out. So the original challenge comes in two phases. The first one, it has this swing arm. It's a kind of junction box. It has a dome shape in the middle and then three pipes coming into that as a mixing ground. Two of these pipes are like the flanges. They are slot shaped, and one of them is a tube. Both of these flanges, these slot shaped pipes, they come in at a horizontal angle, but this pipe comes in as a 6-degree angle, and the dimension, we'll talk more about this 2.35. So this is the phase 1 we'll have to build, and then quickly we'll have to transition to phase 2. In the phase 2, the same structure, but it's a little bigger, it's a little wider. So the height of the model changes, and then the diameter of the dome shape centerpiece gets bigger. All of these dimensions are given in inches. I thought it would be better for me to work on in millimeters only. So what I'm going to do is I'm going to convert these into millimeters, and then right here I have those near about millimeters written down. So 3.35 inches comes around 85 millimeters. So these are the dimensions that I'll be using for phase 1, and then phase 2 will be these values. And between these two phases, we see that these three values are the ones that moving only, the changing. So the very first task of this build would be creating a spreadsheet that has only these three values in there, and start working on the spreadsheet. So on the spreadsheet, we have a spreadsheet workbench. I want to start with a new spreadsheet, rename that as data, and as I said, we will have three parameters here. So we will start from here somewhere. We want to keep this first column empty, and then start from B. So the first one, let's put some name in there. Say overall height is one of our parameters, and these are the names only, and I'll have to put some aliases in here. There are macros available in to do the alias thing easy, but let's go ahead and make it all old school. All right, so there is the overall height, the same name on the description, but on the alias we did not use any space. So that's very important. Do not use any space in the alias. All right, now I'm going to go ahead and enter the phase 1 values in here. Overall height is 85 millimeter. Dome diameter is 70 millimeter. So that is the outside diameter. And then pipe height is given as 60 millimeter. We may have to come back and then work on this 60 just a little bit. And because I will be using a configuration table for this easy one-click switch between phase 1 and phase 2, I want to say here it will be phase 1 values and this will be phase 2 values. So configuration table, I have a video on configuration tables, how to build one. I'll put that link in the description of this video. So take a look at it, how to create a configuration table if you are new to this. And now what I want to do is I want to go in here. So this is the cell, very important. right click on there and then hit configuration table, and then in the property we want to say phases. In the group we want to say parameters. The parameters, the name that we gave, and then phase. So the phase one that we typed in first, parameters was the one we typed in second. So now we have phase one. So these are the one selected values in phase one. And if we go to phase two, these are the values that's pulled in into this here. So that's the configuration table. Right? Okay, so we have our configuration table set up. Let's put it into phase one. And then now I want to start sketching. So go to part workbench and then draw a sketch on, let's say, YZ plane. Maybe XZ plane. There. So on this one, I would like to put the values from the configuration table in here, because this value will be coming from the configuration table, this one and this one. So one way to put them side by side, I have these two tabs open. Now I can go into Windows and hit Tile. So that puts these two windows side by side. However many windows you have open in here will be placed side by side, or like here. All right, that now we have access to our data. So we want to start as a dome, and in here, so because it's a dome, we can do only half of it. So let's start with a polyline. Start from the technical drawing, this and this and this and this, all four of these geometries will be the same. Okay, and these two will be at the same, these are the center of these two arcs. And okay, now this overall height, now we can go ahead and apply that dimension in here. So the overall height is given as 85, the phase one. So let's see, take it all the way up there and then say the overall height is equal to, we go to data and then we can say overall height. So that's the one we entered in there. So we got that. And then I see something messed up here. Okay, how about we place these two as a coincidence, C on the keyboard, and maybe take these two and then put them in the vertical plane so they will be aligned. And the next, let's place this thickness, which is 6.5 millimeter. Got that. And we can say this diameter is the dome diameter. We can say data, actually hit and equal to, and say data dot dome diameter. Now we are drawing only half of it, so it will be divided by 2, makes it radius there. And we have 1 degree of freedom left, which is this length. That one we can get from the standard drawing. The technical drawing, it has 95 the whole thing, so this is going to be 95 divided by 2. That's our fully constrained first sketch. Let's go ahead and rename that as sketch dome, right? And then revolve it around z-axis. There, our first part built very easily. Now I want to see if our configuration table is working. In fact, throughout the process, I'll be doing that very often, just to make sure we have all the data keyed in. So you can see that dome is changing its size between phase 1 and phase 2, which is great. So the keyed in data and the configuration table is working. All right, moving on to these flanges. Both of these flanged pipes are the same, right? One thing to notice is that center hole goes through the dome, but these two ones, these smaller ones on top and bottom, they go 1 inch inside. It said here, so 25 millimeter inside, and it doesn't go through it. So we'll have to keep that in our mind. And also we are working with part workbench. If it was in part design, at least that part would be easier. Okay, I want to draw that on this face, on XZ face. So XZ, right? And then one more thing here. I want to draw it outside, and then I can extrude it inside. So that way we can draw it at 70 millimeter offset. Let's make that 70, right? And hit OK. Right. So I think it's taking it from the other side, which is okay. It's not that bad. All right. So we draw a flange. Start with a slot of radius 10, right? And then I actually don't want to fix it with the origin. I want to keep it floating somewhere there, right? And then break these two lines in the middle. So now we can spread them out. Oh, we can take this vertical constraint off first, like there. All right, now let's do the obvious. Put two holes, top and bottom, and one in the middle. These two are going to be equal to 10 diameter, and then this middle one is 19 millimeter in diameter, and these two smaller holes are 38 millimeter apart. Centers are. And now let's see, we want to place it on this axis. Let's apply some tangency in this area, right? And then it looks messed up. So let's take these two center points and then make it symmetric by the center point. All right, one more thing to do is to make rounding at these two edges, and then let's make these two arcs equal. Let's take these two center of those two arcs and then put them at the center, right? And then let's say this diameter, this radius is 15. What else? We have 1 degree of freedom left, and that's where not tying this to the origin comes in. So now we have this moving up and down. Let's take a look at this drawing one more time. We have the flange finishing at the top of the dome. So this top point ends at 85. So what we can do, we can take a dot point, put it on this axis, right? So it's at the topmost point, and then we can say take this point and then make it at 85, right? That does the trick. This will place that at the same vertical level. But my experience on this says that because we will be moving this 85 to 115, that back and forth, somehow that point that we just placed gets misplaced. It comes down on this circle, and I don't know why. And that's why what I found working is that instead of making that point to 85, what if we took that 85 and then made that right here, right? So we want to tie that height to the center of the flange. That way, if everything flips, it's still the same thing, right? So take that point, hit D on the keyboard, and on here, I want to draw that everything from the data sheet. Say data dot overall height. So that's 85. We'll have to take this 10 millimeter radius out of there. So minus 10. And then take half of these two center distances. So it was 38, half of them is 19, so minus 19. Now both of these 10 and 19, they are fixed between phase and phase 2. So don't have to worry about that. Only thing variable is this overall height, right? So hit OK. and then I'm going to say this is reference height. We may be able to use that later on. Right, so this is 56 millimeter. On the technical drawing, it has 2.23 inches. It says reference, which means either of these, like these two, are conflicting to each other. If you apply both of these constraints on this sketch, it will be over constrained. So you either apply 85 or you take 2.23 and then take 85, like 3.35 as your reference. So 2.23 converts to 56.5 close about as reference. What I did is I take that as my driving dimension and take this one as my reference. So this is that 56, although I say it's reference height, this is actually driving in this case. All right, so we have that, right? And now I want to extrude that so it comes all the way down here. Now before I do that, think about it. If I extrude the whole thing, these two holes will be through holes, which in our case stops like halfway through. So what I want to do, I want to take this sketch, right, and then copy it, only the sketch, not the data sheet, and then paste it. So I have two sketches the same thing, and I want to go into the first one and take these two circles and make them construction geometry GN. So that way the first one has this through thing that I can extrude all the way to, and then second one, let's take these two, make them construction geometry, and then take everything and make everything construction geometry. So that way whatever the solid was, now construction, whatever the construction was becomes solid. So that's one easy trick to make reverse construction. So now what I have is one sketch with two holes that goes halfway through, and another sketch with everything goes through. Right, so let's say sketch plot 1, and then second one is sketch plot 2. I forgot which one is which one. So the first one goes all the way through, right? And that distance is 70 millimeter because we placed that at 70 millimeter offset. I want to extrude that to 70 millimeter. Hit OK. So that one goes through. It comes in here up to the center. All right. And then the second one right here, we want to extrude that for 25 millimeter only. There. So there is two 25 millimeter holes. Now what I can do, because it's in part workbench, not part design, we'll have to make this deduction manually. So I want to keep this part, I want to delete this part and hit cut. That's it. If it was in part design, it would be easier, just make a pocket. Only thing we are doing this in part, not part design, because this next phase. I want to use this connect object, which makes things much easier. So let's take this one, rename that as dome, and turn on transparency on that. There. So now you can see, maybe make this one say red. There. So now what you have is this slot divided at this point, at this line. And if you kind of like eyeball it, this divided outside part is a little bigger than the inside part. So what this connect object does is between these two objects, it will split it at that line and then keep only the larger parts of this two fraction and then delete these smaller parts. So if I take this dome and this cut, this flange, I'll rename that, and hit connect object, it deletes that smaller part, it deletes that whole covering and then makes it one piece. And this is what we need for this model. Let's see if our data sheet is still working. We go to data and then hit say phase 2. Yes, this is still converting between phase 1 and phase 2, which is great. That's what we wanted. All right, I don't want to do this connect operation right now. I want to do it at the last step. So delete that for now and then rename this as say slot pipe. I don't know if that's the right terminology. I just wanted to use that because it looks like a slot. All right, now what I want to do is I want to take this same thing, move it over here 45 degrees on the right, and there are like multiple ways to do that. So what I'm going to do is I'm going to use the clone tool from the draft workbench. I have that in here as my shortcut. So right here, so use that and transform it. So I have 15 degrees increment. So 1, 2, 3. So that's 45 degrees transformed. And I want to use that because I want to be able to select it separately, right? And that's important. All right, so out of these 1, 2, 3, 4 part, we built already 3 parts, and we want to work on this pipe. For the pipe, I don't have a standard plane going at 45 degrees angles in that direction. So what I want to do is I want to go ahead and draw a sketch on XY plane. Oh, I don't know where I am at. There. And I want to draw a line right there, say 100 millimeter, doesn't matter how long it is. And I want to make it at 45 degree angle there. And that is going to be my datum plan. And I want to extrude that upwards, say 100 millimeter. Again, height doesn't matter here. This is a datum plane. And all I want this to draw a reference line. So let's go ahead and rename that as datum plane. Again, it would be easier if it was in part design, but we are choosing part workbench only because of this connect tool. I want to draw and sketch on this datum plane right there and attach it with that face. So this is where we are at, and this button will straighten that drawing. And now I want to take a look at our technical drawing very closely. Here it says on this one, so there is this 6-degree line that is the axis of that pipe that goes to meet this vertical axis at this point, which is right here. It doesn't say how above it is, but we can infer that this line is the same center as this. So that would be 56, or this reference millimeter above the axis, above this origin. So this height, this point is coming from this slot. So we'll have to remember that. Remember we said reference height. So we'll be using that to find this point. And then we draw this 6-degree angle line. And so for this point, we can find that from this 2.35 inches height. So which is 60 millimeter in this case. So the bigger this number is, the longer this line will be, which means that the bigger this number is, the longer this sketch, this will be pushed outside. And that we want to find that point very precisely. So with all of that analysis, let's go ahead and draw a line. So this is the horizontal line that actually will give us the center, and then this is that 6-degree inclination. So let's go ahead and say the angle between this is 6 degrees, and then this height is coming from that sketch that we just built. So that would be sketch, I'm gonna say slot 1, either of these, 1 or 2 will work, and then go to constraints and then say height there, reference height. So that puts this sketch right where the center of this slot is. You can see in the background, so we are good on that. This length, because this is the horizontal line, it doesn't matter, so let's put some dimensions in there. 100. Now to find this line, the length of this line, we go with that height. So that height is given as, on here, that's the pipe height. Oh, I don't see that data there. So maybe let's make some room for that. There. All right, so this point is going to come from that data dot. So this is going to be pipe height, right? There. So this is where I said I'll have something to talk about. So 60 millimeters, that puts it right about there. I want to make that 61. So let's see, hide this and hide this dome. So this is what we just drew, right? Now I want you to take a look at this, where this point ends. If I go in there and then in the data sheet, I want to make that a 61. This kind of like increases and make that 62. It gets more. 65. That's way more. I'm doing that because looking at this plan from the above, this length of this pipe, it looks like it's a little less than this one, but it's not a lot less. So to match with that, I think somewhere between 62.5 or like 62 will do for us. And this 60, where it says 60 here, the 2.35, actually I have doubt about this number. So with a ballpark in here, let's go with 62, right? And if it is 62 on the next drawing, I want to make that as 92. We'll see where it leads, but know that this value is kind of like questionable on the technical drawing. We are going with the ballpark. Maybe 62.5. I don't know. Yeah, let's go with 62.5. But it is important for us to find that length because we'll be drawing a sketch and then placing it right there. All right, let's go ahead and draw that sketch on XY plane. And this is going to be two straight circles, nothing else. So the outside diameter of this circle is given as 30, and the inside diameter of that circle is given as 20. There. So that sketch is sketch pipe, right? And then this one is the sketch, the pipe reference. So I want to go ahead and take this sketch from there, take it up here. So I want to go in the data tab in where it says map mode deactivated. I want to go in there, find these three dots, and then from here it says select attachment. First attachment I want to select is this point, that vertex. And then second, where it says selecting, I want to select this line. And then come here and says attachment mode, go to normal to edge. So that places it in the normal direction, orthogonal fashion. So there we have that sketch fixed up. Now what we can do is we can take this sketch, extrude that up to this length of this line. So we don't have to worry about the length anymore. We can go with along edge and then select this edge, right? And then hit apply. And I see it went to the wrong direction. Well, the other direction, not wrong. So we want to make it the right direction. There. So we have, I can hide this. We have the dome and we have three pipes. Two of them is like parallel and horizontal. And this one is 6-degree inclination. Now I want to take each of these and apply this connect tool individually, not all together. So don't come here and then put them all into a fusion and then do that one time. It will not work. So I want to take this dome and that pipe, make a connect. So that part worked. And so take this one and take this slot pipe, make another connect object. Now take this connect, this final one, and take this pipe. Maybe I want to rename that, say pipe. So take this connect and take the pipe and do another connect objects. So in here there are 3 different modes. I'm using the connect object. These 2 are for different purpose. So I have a video describing on these 3. I'll put that link in the description of this video. Take a look at it. Right there, we have phase 1 completed, right? Except the fillets, and given how problematic fillets are in FreeCAD, I decided not to bother with them on this model. So now let's see if the phase transition works. It works perfect. Oh, it did not for the third pipe, because I'm guessing the third pipe, this length outside was a little less than what we needed. This 92 is controlling this length of this pipe, and then if we delete that connect, we can see that the outside length is smaller than the inside length. So this one is getting deleted after the connect operation. Let's see if a 92.5 works. Actually, I want to put them together, and still no change. So 93 there. And I wish it's a smaller length. I wish these values are like, I think, are not up to par. And so I wish this length was given instead of this angle type kind of thing. That way we would not have to go through this trial and error. But so 93 works for this one. Let's see. Go back to data, phase 1. So phase 1 works and phase 2 works. Alternatively, we could do another thing, is what if it was smaller on this side, right? We could instead, we could do this one too. So let's go back to phase 1, right? And then delete this connect. So we want to modify this pipe. Instead of taking it all the way inside, we could come to like somewhere here, right? So that way we would not have to worry about this value. So that was another alternative that I have in my mind. So delete this pipe, here is the sketch. Instead of taking this reference as our go-to for the extrude height, what if we just push it down, say 50, right? And see if that crosses that edge. So it actually crosses more than what we need. So maybe we make that limit, say 40. See, it's not crossing the whole thing, but still let's give it a try. So, and it was 92. Let's bring that original back. And now I want to rename that as pipe and put this together, right? And actually it worked. So that worked. As long as this hole is crossing this edge, I guess it works. And now let's try this phase 2. Yes. So it's a much shorter pipe, but still, so we have that freedom based on what it is in the technical drawing. Let's see if 93 would work. Actually, if the 93. Yes. So that's more like it. That's more the length that comes from the technical drawing. Here it is, a working version of this model between phase 1 and phase 2. They are going back and forth without any issue. I want to do another thing right before finishing this model. So now you see how we have to change it. Every time I have to change it, I'll have to go to the spreadsheet and then switch it phase 1 and phase 2. if we could do it from here, it would be much easier. So we can do that still in the configuration table. So go to data in the spreadsheet, right there in the corner where we set up the configuration table originally. Go in there and then go to configuration table. And where it says phases property, we want to place this object's name in there. Okay, so we want to do that. So the object's name is connect 002. So say connect 002. There it is. And there. Dot say phases. Now what it does is that option is coming into this version, this object. So we don't have to go in here and then change it. In fact, this one will not work anymore. So if we change phase 1 and phase 2 from the data sheet, it will not work. We'll have to do it from here. So now we can actually not worry about the spreadsheet, make this one our only window there, and then set it up right there and say go to connect and go to phase 2. Pretty cool. And phase 1. Awesome. Now I say let's try this one. I want to make this Model Mania 2000. So that's the object's name. See if that parameter works now. So renaming the object did not affect our configuration table. So if we did this fillet, the nice fillet that we have on the model, if we did that, this transition will not work so easily. And because I want to focus more on the transition, not on the fillets, so I'm skipping that fillet part. Well, my friends, I hope you liked it. You saw the reasoning why we did it in part workbench and why for this model part workbench is much better. We didn't have to scoop out this retaining part inside with any other methods. Had it been done in part design workbench, this connect will actually makes it way better work for us on this one. So if you have any question, comment, suggestion on this model, or if there is a better way to do this in FreeCAD, let me know in the comment section below. And thank you for watching. I'll see you in one of my next videos then.